Okay, we're going to factor the polynomial and then find the roots, okay? Actually, we're going to find the roots in the process of factoring the polynomial. Okay, so we're going to use a variety of theorems to accomplish this. First of all, we're going to start off by trying to identify any potential roots of this function, okay? And we're going to use the rational root theorem. Rational root theorem. Okay, which means I'm going to take this constant term. Really, I'm just going to focus on the positive 8. Okay, I know it's negative, but we're going to focus on the positive for now. Doesn't matter. And then this understood 1 in the front here, the leading coefficient. And I'm going to write out all of the factors of 8 and all of the factors of 1. Okay, they include for 8, 1, 2, 4, and 8. All those numbers divide evenly into 8. And the only number that divides evenly into 1 is 1. Okay, so now with this, I'm going to make fractions out of these. Remember, 1 over 1 is 1, positive and negative 1. 2 over 1 would give me a positive and a negative 2. 4 over 1 would give me a positive and a negative 4. 8 over 1 would give me a positive and a negative 8. Okay, so that's 8 potential roots. Okay, now I'll go through the process of plugging them all in to try to identify as many roots as I possibly can. So how many actual roots do I have? Rational roots, that is. Well, again, it depends. If I plug in 1 for x, if I plug in negative 1, and so on, do I get 0? Okay, that's where I'll use a calculator to do this quickly. So I'll type into my calculator x to the third plus 2x squared minus 4x minus 8. And then I will set my table to start at negative 8 because negative 8 here is the most negative potential rational 0. And I'm going to have it count by 1s because I don't have any fractions in here, so that's good enough. So change, it will be by 1. Okay, so now my table is ready, and I know you can't see my table here, but it gives me a list of x values and y values, and it starts with negative 8 and negative 7 and negative 6 and so on, and it plugs in numbers to give me the y values, right? It plugs them into the function for me. Okay, so sure, this is kind of, I'm not going to write all this out obviously, but this would quickly give me my roots. They are negative 2, positive 2, and that's it. Negative 2 and positive 2 are the only ones that I found. Okay, that doesn't mean that there are only 2 roots. You know, we should expect there to be 3 roots, okay? But we're going to use this as a guide. So first of all, remember, the factor theorem says that, okay, well, if you have any roots, then you can at least factor your function partially as x minus the root. So in this case, negative 2. X minus negative 2 makes this x plus 2. X minus positive 2. And then this unknown blank here, this unknown. Okay, so I'll just leave it blank for now. To figure out what goes in that blank is when I'm going to switch to synthetic division. Okay, so do we remember synthetic division? Well, hopefully we do. Okay, so synthetic division says we're going to take the original function, this x cubed plus 2x squared minus 4x minus 8, and then divide it by each of these individually. Okay, so practically speaking, I'll start off by writing out x cubed, x squared, x constant, and then the coefficients. The understood 1 in front of x cubed, the 2 in front of x squared, the negative 4 in front of x, and the negative 8 for the constant. Okay, and then I'll start off with this first root that I found, negative 2. drop down the first 1. Negative 2 times 1 will give me a negative 2. 2 minus 2 is 0. Negative 2 times 0 is 0. Negative 4 plus 0 is negative 4. Negative 2 times negative 4 is a positive 8. Negative 8 plus 8 is 0. Okay, so far so good. Now let's use our next root here, 2. Understanding that when I divided this first time, it knocked down my my quotient, my result, by a degree, so it's not going to be x cubed anymore. All right, so again, let's do this process. Drop down the 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4, positive 4. Negative 4 plus 4 is 0. Okay, that knocked this down again. I'm left with this positive 1 and 2, which correspond to this x and a constant. In other words, 1x plus 2. Well, that's going to be my blank here. 1x, or just x, plus 2. Okay, so there we go. We factored the polynomial. Now, to find the roots, okay, that's the last step here. Let me change colors here so we don't have too much going on. We already know that negative 2 is a root and that positive 2 is a root. Okay, well, remember, this negative 2 gave me this plus 2 here. This positive 2 gave me this minus 2 right here. Okay, I have another plus 2, which means I actually have 2 negative 2's. Remember, that just means that you have a multiplicity of 2. Okay, that means you have more than 1. You have 2 negative 2's. Okay, and then you can say that this one has multiplicity 1, or just leave it as 2.